All right, so this is section 4.6. This is the more advanced usage of all of our material. We're trying to show triangles congruent using all of the tools that we have available to us, and the triangles are going to be overlapping. Okay, so here are some guidelines that might help you out as we go through our examples today. First, identify the two triangles that you want to show congruent. Identify the parts you know are congruent. Identify what you still need. Use a triangle congruence property to show triangles are congruent. Use your theorem definitions toolkit that you've created to help you find missing information. And lastly, sometimes it might be useful to split the two triangles apart. Okay, split off your triangles to see more clearly what it is that you're trying to show. It helps you in identifying things. Doesn't mean you have to. Sometimes it's just beneficial to do so. So these are all the guidelines you can follow. Okay, these are the things you're trying to accomplish as we go through these examples. So this is basically just examples of showing proofs of things that are congruent using the information that we learned previously. So let's go ahead and do some of these together. There's 3 examples that I have, it looks like. So let's start with number 1 here. What are the corresponding sides and angles in these two triangles? Okay. Now remember, in the ordering of these things, we can look at this stuff. Sometimes, like I said, it might be beneficial to split things apart, but walk through the shape. So F, H, J. F to H to J. That triangle right there. This angle to this one over here. And then K, H, G. K, H, G. So we can see that that's the same ordering as this one was. Okay? So what are the corresponding sides and angles of this thing? Well, if these things are congruent, which they will be, again, if you pull the triangles apart, even though these are split apart, these combine to be a congruent segment with this side over here. A 1 and a 2 together, combined with a 1 and a 2 together, give me a congruent side. So I have an angle and I have a side, and H is the same angle in both triangles. If you have a hard time seeing it, we can redraw the triangles. So here is F, here is H, and here is J. And then over here, it would look like this. And this over here would be G and H, and this over here would be K. I know that's congruent to that. This is congruent to this. And H is congruent to itself. So by angle, angle, side, the two triangles are going to be congruent, which means all corresponding parts are congruent, which is what they were asking. If the triangles are congruent, then what are the corresponding angles? Well, F and K. Okay, so you need to name these things based off of, you can probably name them by a single letter. Yeah, I think we can. So we can say angle F is congruent to angle K. If you can't tell by one letter what the angle is, then you have to use a 3-letter name. That's what I was checking, by the way. Angle H is congruent to itself. And then angle J will be congruent to angle G. Those are the corresponding angles and the corresponding sides, FH, KH. FJ will be congruent to KG. And then HJ will be congruent to HG. So I'm just following FH, KH, HJ, HG, FJ, KG. So that's how I kind of figured those out. Okay? Next example. Are these sides congruent? Is this side going to be congruent to this side? And if so, how do we know? Okay, how do we know this? So we need to find all the pieces that we have and see what is correspondingly congruent, what more I need to show that they're congruent, and then go from there. So one of the things, again, that might be useful is to split the two triangles apart and see where the corresponding parts are. It doesn't mean you're only going to focus on that. It just helps you see what you have and what you might need. So here's the one triangle right here. See it? So I try and draw it in the same orientation. It helps me visually. And then the other one is this one. Again, it doesn't have to be perfect. This would be V, this would be Z, and this would be Y. In my pictures here, this is the big angle V, and it is the same as the big angle Z. So those two angles will be congruent. The small little angle up here is in these little tiny triangles, so it's not part of these big ones. But I do notice that this is a shared side. See, I can see it's a shared side, so I know that it's congruent to itself. So I know that. So what I need to do is try and figure out a way to get another angle or another side to be congruent. Okay, and I look at this, I don't really see anything coming to mind right off the bat. So I need to do some more exploration. Right? I had this other angle they gave me, so this angle down here is congruent to this angle over here. So can I figure out some other side? Okay, is there something else I can do to figure out something else that might give me some information that I would need? There's a couple ways we can do this, and let's see what we can do. What do I know? Well, in the small triangles here, these two angles will be congruent because they are vertical angles. So that gives me two angles in this triangle. Can I get anything else? Is there anything else jumping out at me? Okay. Well, I got some linear pairs. I got some of that going on. So there's a lot going on here. So let me show you some of the, I found like two different ways to do this problem. Let me walk you through them. And I'm just going to show them to you because they're kind of long to write. And I don't want this video to be too long. So let me go ahead and show you the two methods that I have shown for this one. And let's walk through them. Okay? So the first method that I had was right here. So I can zoom in just a bit. So I started off with this one. I used the three-letter naming when I wrote this out the first time. So WVX. WVX is congruent to the other ones. They have the same measure. Okay. And then I talked about the vertical angles being congruent. So based off of that, what I was looking for is I'm showing you how I can get these two angles up here to be congruent. Okay. Because the three angles of a triangle have to add up to equal 180. So that's how I did it. So I just added the three angles. So here's W, and then this one down here, and then this one equals 180. And then these three add up to 180. And two of the triangles in there are identical. Okay, so when I subtract these two rows, I'll get that minus that equals 0. Because these drop out, those drop out because they are identical angles, congruent angles. And so 180 minus 180 is 0. And that gives me that these two angles are going to be equal in measure, which means they are congruent. Okay? And so what that does then is it gives me these two angles being congruent. Since these two angles are congruent, that was the third piece that I needed. Then the two big triangles are congruent by angle, angle, side. because these two triangles are congruent, corresponding parts are congruent, and that's how I got VW equal to that one over there. So that is one method that I saw. Here's another method. Like I told you, there's always more than one way to do something. In this method, something very similar. So the whole thing here was trying to get to follow the thing. So WVX, so WVX, and that's this one over here. Okay. And XVZ. So this one plus this one. So this angle plus this angle is the whole angle, is what it's showing you. So this angle plus this angle is the whole angle. And then I do the same thing over here. This angle plus this angle is the whole angle, angle addition. And since I have congruent pieces, when I subtract these things, notice what I have, XVZ. So this one right here, XVZ, will be congruent to this one. In other words, these two angles are going to be congruent. Is what I just showed by angle addition and subtracting these two quantities. And so now those are congruent. Then the triangles are congruent by angle side angle. And then again, these two pieces will be congruent by corresponding parts. Sorry, you couldn't see it. There we go. So that's what I pulling things apart, knowing what you need to find by congruence properties. I need to have another corresponding angle congruent. So I showed you how to get these angles congruent. And then I showed you just now in this method too, how to get those angles congruent. So either one of the two methods led to the conclusion that we were looking for. Okay? So when you write these things out, that's what you're trying to do. You're trying to find ways to do it and using your knowledge to help you get there. This is why your toolkit is so important to you. Here's the last one. Show that those two triangles are congruent. So there's a lot of stuff in here. It gets kind of busy. That's what I was talking about. It gets kind of busy, so it's kind of hard to tell. So the first thing you do is identify the two triangles you're trying to show. SRV. SRV. This big one right here. PUW. That's that one right there. If I pull those apart, you will notice here's S, here's R, here's V. Here's W, U, T. That's 90, that's 90. That's congruent to that. Well, what I have here is I have, oops, get out just a little bit more. I have now, I can see clearly that I have two right triangles. And one side is congruent. By hypotenuse length, if I can show that this side is congruent to this side, then I'm done. The two triangles will be congruent. So can I get those two sides to be congruent? Is it possible for me to do so? Okay, with that clarity in mind now, I can come and look over here and see in this mess in the middle, I have this triangle and I have this triangle. And if you look closely at it, you'll notice that I already have two angles congruent in that triangle. So all I need is some side. And sure enough, those two triangles share that side right there. So if I look at those triangles, this is S, T, and this is W. This is S, T, and this is V. And V and W are congruent. This angle is congruent to this angle. And this side, I just got to state that that side right there is congruent to itself. So ST is going to be congruent to TS. It's the same side. we have angle W. Let's use the full letter, I guess. You know what? That's not. Based off of what I see over here, so we'll just go right to the triangle. So triangle VST will be congruent to triangle WTS by two angles in the side. That makes the diagonal VS congruent to WT. Is going to be congruent to WT by corresponding parts of congruent triangles congruent, which makes triangle SRV congruent to triangle DUW by hypotenuse leg. So you can see how I use the guidelines to help me figure some of these problems out, splitting triangles apart. It makes it a little bit easier to see what I have and what I need. And very complex looking stuff, okay? So that's what I would do, and we'll do more together, and that ends this video.